Hello, today I'll be starting off with the UR5 robot, specifically its jog features. Using the Teach pendant, you can see we're in the Move tab and can use the arrows to jog the robot in either a linear or rotational direction. I don't use it here, but we can also move the individual joints using the bottom right arrows and coordinate system. Moving on to an automated program I made, the robot moves through two joints and one line move to pick up a cube and set it in a new location. I use a line move to move the cube while it's in the air to simulate a time when space is tight and movement needs to be constrained to a linear motion rather than following the arc created by the rotation of the robot's base. Lastly is the UR5's palletization. We use the selection of points to create the four corners of a 3x3 grid and another point for the entry and exit positions to prevent the end effector from crashing into our blocks. The robot uses the four corners to create an even divide between the number of blocks in each row and column to calculate the spacing between each cube, creating the symmetrical pattern throughout the pallet. Moving on to the Omron robot, I can use its controller menu to jog the robot in a similar fashion as the UR5. In the Joint tab, we can move each joint freely by using the plus and minus keys or by typing in a specific coordinate by pressing the Move key. We can also switch to the Tool tab to move the robot based on the position of its end effector. Next, we'll move through an automated program I created using a series of point-to-point commands, a joint move, and a line command. Point-to-point and joint movements are the easiest to create here, but I found that line movements needed to be carefully considered and to plan the path of the end effector to keep it from crossing the base of the robot, potentially locking its joints from over travel due to it moving in the opposite direction that you wanted. Lastly is the Omron's palletization. This works very similar to the UR5 robot except that it only needs 3 points for the grid rather than 4. It uses the 3 points to set boundaries for an X and Y grid and then divide that space evenly by the number of units you selected. We once again had a centralized point for our entry and exit to prevent the robot from running into our palletized cubes.